Hello there, weary traveler. Welcome back to the Sleepy Wiki, where curious minds drift into slumber. As you settle in, perhaps let your shoulders gently drop and simply breathe, slowly, deeply. Tonight, we journey to the very edge of possibility, far beyond our familiar sunlit skies. Imagine, if you will, the profound silence of the cosmos. And within that vastness, the most enigmatic objects known to existence, black holes. Could civilizations, ancient and wise, have found a way to not just survive, but thrive in their gravitational embrace? We'll ponder the whispered tales of cultures drawing unimaginable energy from the event horizon's kiss, stretching the fabric of time to their advantage, and perhaps even holding the universe's deepest secrets within their informational grasp. It's a gentle exploration of cosmic wonders designed to ease you into a peaceful rest. If these whispers of far-off worlds bring a sense of peace, and if you find comfort in these quiet journeys, please consider gently tapping the like button or perhaps even subscribing to join our sleepy community. It helps these calming whispers reach more drifting minds. But for now, let your thoughts drift. Allow your imagination to settle upon the vast, dark ocean of space as we begin to contemplate the astonishing concept of civilizations shaped by the very heart of darkness, the black hole. Civilizations built around black holes would find themselves at the nexus of immense cosmic power, a place where the very fabric of space-time bends to offer incredible advantages in energy, time, and information. Imagine, if you will, a future where humanity, or perhaps other intelligent life, has mastered the delicate dance around these ultimate cosmic engines, not merely surviving, but thriving in their profound gravitational embrace. Let's first consider the extraordinary energy advantages that a black hole offers. These aren't just cosmic drain pipes. They are the most efficient power plants in the universe. Picture a supermassive black hole, perhaps millions of times the mass of our sun, at the heart of a galaxy. Around it, swirling like a colossal whirlpool of fire, is an accretion disk. This disk is composed of gas, dust, and stars that have ventured too close, spiraling inward, accelerating to incredible speeds, and frictionally heating to temperatures hotter than the surface of any star. From this incandescent maelstrom, radiation streams forth. X-rays, gamma rays, visible light, a beacon of pure energy so bright it can outshine an entire galaxy. A civilization could harness this light, perhaps with vast fleets of orbital collectors, akin to capturing the sun's warmth, but on a scale so grand it defies easy comprehension. Think of a city not just powered, but illuminated by the radiant glow of a star-eating monster. Its energy needs met with a cosmic bounty that seems limitless. But the energy potential goes deeper, into the very geometry of space-time itself. For a rotating black hole, known as a Kerr black hole, the space-time around it is not merely bent, but dragged along with its spin like a cosmic vortex. Within this swirling region, just outside the event horizon, a brilliant theoretical mechanism called the Penrose process becomes possible. Here, a craft or even a specialized station could descend into this swirling ergosphere, release a portion of its mass in just the right way, and then, by meticulously recapturing another part, rebound with more energy than it had initially. It's like dipping a bucket into a cosmic current and pulling it back out with more water than you put in, essentially extracting rotational energy directly from the black hole itself. Imagine entire industrial complexes, not merely gathering energy, but effectively mining the rotational kinetic energy of the black hole, turning its colossal spin into the lifeblood of a civilization. This wouldn't be mere sustenance. It would be power on a scale that could reshape worlds, drive interstellar fleets, and fuel computational networks spanning light years. Then there are the profound time advantages offered by these gravitational behemoths. This is where the magic of Einstein's relativity truly comes alive. Near the immense gravity of a black hole, gravitational time dilation takes hold. Clocks tick slower the deeper you descend into the gravitational well. For an observer safely far away, watching events unfold near the event horizon, time would appear to crawl, stretching minutes into hours, hours into days, and days into centuries. For those living within the black hole's immediate vicinity, however, time would proceed as usual for them. A year would still feel like a year, a day like a day. This isn't just a curiosity, it's an unparalleled advantage. Imagine a research station orbiting close to the event horizon. For its inhabitants, a year might pass, filled with intense scientific discovery, advanced computations, or the slow, careful construction of monumental structures. Yet, for the rest of the galaxy, 1,000 years, perhaps 10,000, might have elapsed. This means a civilization positioned near a black hole could undertake projects requiring vast stretches of objective time, developing advanced artificial intelligences, refining technologies over countless generations, or conducting simulations so complex they would take eons to complete in normal space, all while experiencing only a fraction of that time subjectively. It's like having a cosmic slow motion button for progress, allowing for an incredibly dense and accelerated internal development from an external perspective. Such a civilization could evolve intellectually and technologically at a pace unimaginable to those living in the shallow gravitational fields of ordinary stars, becoming a beacon of advanced knowledge and capability across the vastness of space, a living, thinking entity that ages on a different cosmic calendar. Finally, let's consider the fascinating information advantages. While the notorious information paradox still tantalizes physicists, black holes, particularly due to their immense entropy, represent the ultimate cosmic memory banks. The entropy of a black hole, which is a measure of its disorder, scales with the area of its event horizon. This is an unfathomably large number, suggesting that an extraordinary amount of information could, in theory, be encoded within its very structure. While the practicalities are still purely theoretical, some speculative ideas suggest that a black hole could act as a universal storage medium, where information isn't merely stored, but is an intrinsic part of its fabric. Imagine a civilization that views the black hole not just as an energy source or a time machine, but as a colossal natural quantum computer, or the most stable, longest-lived data archive imaginable. They might harness the unique quantum physics at play near the event horizon for computation, using the black hole as a stable, cold, and incredibly dense environment for processing information on scales that dwarf any silicon-based system. Furthermore, the extreme stability and isolation provided by orbiting a black hole could be ideal for ultra-long-term data storage and retrieval. With time dilation extending the lifespan of any data-holding medium to cosmic scales, a civilization could safeguard its entire history, its accumulated knowledge, and its cultural heritage for quadrillions of years, effectively ensuring its immortality through the preservation of its essence. It would be a cosmic library, its shelves laden with the wisdom of ages, ticking forward at a pace so slow that it would endure well beyond the lifespan of the stars themselves. These three profound advantages, boundless energy, malleable time, and ultimate information potential, weave together a tapestry of possibility. But of course, such a profound undertaking comes with its own unique set of challenges, and it is to these cosmic obstacles and the ingenious ways a future civilization might overcome them that we shall turn our thoughts next. Let us begin with the most daring of all, the construction of habitats in the very heart of these cosmic forces. Imagine, if you will, a place where the very fabric of existence twists and turns, not like a gentle river current, but like an immense, silent whirlpool in the cosmic ocean. This is the ergosphere, a region found only around a very special kind of black hole, one that spins, a Kerr black hole. It's not the black hole's event horizon, that definitive point of no return, but rather an outer ring where space-time itself is so profoundly caught in the black hole's dizzying waltz that it is dragged along, compelled to rotate with it. For anything within this swirling embrace, there is no possibility of remaining still relative to the distant universe. You are forever swept up in the black hole's gravitational dance. The genesis of habitats here, of what we might call ergosphere worlds, begins not with natural formation, for such a violent, dynamic place resists the gentle birth of planets, but with an act of profound ingenuity. It's the ultimate challenge for a civilization seeking to transcend the limitations of conventional living. To construct a home in the ergosphere would be akin to building a city on the crest of a perpetual, silent hurricane, or anchoring a delicate flower in the heart of a cosmic vortex. It demands materials of unimaginable strength, structures capable of resisting, or more cleverly, utilizing the immense tidal forces and the relentless space-time drag. These aren't just buildings. They are marvels of dynamic equilibrium, perhaps massive self-correcting structures held in place by exotic propulsion systems, or even harnessing the very forces that threaten to tear them apart. The primary allure, the very seed from which these ergosphere habitats would spring, is an extraordinary phenomenon known as the Penrose process. Picture a cosmic slingshot. A civilization sends a probe, or even a part of its habitat, into the ergosphere. At a precise moment, it ejects a piece of itself. One fragment falls into the black hole, while the other, having stolen some of the black hole's rotational energy, escapes with more energy than it originally had. It's like siphoning power directly from the black hole's spin, extracting its kinetic energy to fuel an entire civilization. This isn't a fleeting spark. It's a boundless, sustainable power source, enough to illuminate vast cities, power unimaginable technologies, and sustain life on a scale we can barely fathom. The habitats, therefore, would be built with this energy tap at their core, their very existence woven into the dynamics of the black hole's spin. But the ergosphere is just one layer of this extraordinary cosmic onion. Just beyond, or sometimes feeding into it, lies the accretion disk, the accreting worlds aspect of our story. Imagine a colossal, luminous pancake of superheated gas and dust spiraling inward toward the black hole, fueled by the gravitational hunger of the singularity. This isn't a solid surface, but a raging inferno, plasma heated to millions of degrees, radiating X-rays and gamma rays with a ferocity that dwarfs any star. For a natural world, it's a destructive force. For an advanced civilization, it's a treasure trove. The genesis of accreting worlds in this context means the birth of habitats around or above these disks, designed to harvest their immense bounty. These would be colossal orbital platforms, perhaps megastructures forming immense rings or spheres enclosing portions of the accretion disk. Their purpose? To mine the raw materials within the disk. Hydrogen, helium, heavy elements forged in the hearts of distant stars and now caught in this final gravitational maelstrom. Imagine vast, shielded capture nets or incredibly robust electromagnetic fields, carefully skimming matter from the plasma stream, refining it, and building new structures, new worlds, from the very stuff destined to be consumed by the black hole. It's a testament to life's tenacity, finding sustenance even in the maw of cosmic oblivion. Moreover, these accreting worlds would also be massive energy converters. The sheer luminosity and radiation from the accretion disk offer another power source, perhaps even more potent than the Penrose process for sheer output. Imagine colossal solar arrays, not absorbing sunlight, but bathed in the raw, unfiltered energy of an accreting black hole, transforming the fury of gravitational collapse into the quiet hum of civilization. The challenge of shielding against such extreme radiation would be immense, requiring materials and force fields far beyond our current understanding. But the reward, limitless energy, would justify such an endeavor. And then there's the profound gift of time. In the deep gravitational well of a black hole, time itself flows differently, dilating, stretching like taffy for those who reside there. An hour spent in an ergosphere habitat might equate to days, weeks, or even years for an observer far away in the galaxy. This isn't just a curiosity, it's a fundamental advantage. For civilizations dedicated to vast computational tasks, to contemplating the deepest mysteries of the universe, or simply to living a life experienced at a grander, slower pace, this temporal shift is invaluable. Every moment is extended, every thought given more space to unfold, every decision granted more deliberation. It's a profound information advantage, allowing for the processing of vast data sets, the evolution of complex ideas, or simply the enjoyment of a subjective eternity. These ergosphere habitats and accreting worlds, therefore, aren't merely places of survival. They are bastions of advanced civilization, born from the audacity to tame the untamable. They are designed to exploit the very heart of gravitational power, to stretch the fabric of time, and to gain unique perspectives on the cosmos. They represent a fundamental shift in how life might interact with the most extreme phenomena in the universe, turning a cosmic abyss into a cradle of innovation. But what kind of societies would emerge from such an existence? How would a civilization evolve when time itself becomes a negotiable asset, and the very act of living is a constant dance with the sublime and terrifying power of a black hole? That, my dear listener, is a story for another quiet moment. Imagine, if you will, a civilization not merely residing in the gentle warmth of a distant sun, but daring to build their very world around a black hole. Those enigmatic cosmic giants, once thought only to consume, now envisioned as beacons of unimaginable potential. Let us drift closer and see how a civilization might weave its existence around them. First, consider the sheer, overwhelming energy a black hole can provide. It's not the black hole itself that glows, for nothing, not even light, escapes its event horizon, that point of no return. Rather, it's the maelstrom of matter swirling around it, caught in its powerful embrace. Picture a cosmic drain pulling in gas, dust, and even whole stars. As this matter spirals inward, it doesn't just vanish. It forms what we call an accretion disk. Here, particles rub against each other at incredible speeds, compressing and heating up to billions of degrees, radiating away an astonishing amount of energy in the form of X-rays and gamma rays, far more efficiently than even the brightest stars. A civilization could encase this entire region, not unlike a Dyson sphere around a star, to capture every photon, every whisper of energy from this celestial furnace. They might build a vast shell of exotic materials, perhaps laced with advanced metamaterials, designed to withstand and harness the incredible radiation, drawing power from this colossal cosmic waterfall. This energy could fuel their entire society, powering computational networks, manufacturing, and even interstellar travel, creating a truly post-scarcity civilization where energy is virtually limitless. But the energy doesn't stop there. Some black holes, especially those that spin rapidly, known as Kerr black holes, possess an incredible rotational energy. Around such a black hole lies a region called the ergosphere, where space-time itself is dragged along by the black hole's rotation. It's a place where it's impossible to stand still. You are always moving with the black hole's spin. Within this chaotic dance, a clever civilization could employ something called the Penrose process. Imagine launching objects into the ergosphere, letting them briefly absorb some of the black hole's rotational energy, and then splitting them, allowing one part to fall into the black hole while the other escapes, carrying away more energy than it had when it entered. It's like tapping into a giant spinning cosmic top, siphoning off its momentum to power their cities and machines. Such an operation would require incredibly precise control, perhaps with structures built from materials that can withstand unimaginable stresses, subtly reshaping space-time itself through exotic matter constructs to guide and protect their operations. This wouldn't be a mere energy source. It would be a fundamental interaction with the very geometry of the universe. Sun. Beyond these gargantuan energy harvests, there is the captivating allure of time. One of the most mind-bending aspects of black holes is their effect on time itself. According to Einstein's theory of relativity, massive objects warp not only space, but also time. The closer you get to a black hole, the slower time flows relative to observers far away. This phenomenon is called gravitational time dilation. For a civilization living near a black hole, this offers a unique advantage. Imagine different layers of their megastructure, each orbiting at slightly different distances, experiencing time at different rates. An outer layer, far from the black hole, might experience a day, while an inner layer, nestled close to the event horizon, might experience mere seconds. This isn't just a curiosity, it's a profound tool. For long-term projects, such as complex calculations, the development of new technologies, or simply the preservation of knowledge across millennia, a civilization could establish data archives or research facilities in these slow time zones. Generations could pass in the fast-time outer regions, while crucial data processing or the careful incubation of scientific breakthroughs unfolds over eons in the slow-time inner sanctums, shielded and preserved. A single day for an outer observer could be the equivalent of centuries of processing time for a supercomputer near the black hole, allowing for computations of unimaginable complexity and depth. This allows for a kind of temporal multitasking, where different aspects of their society operate on entirely different timescales, a living testament to the malleability of existence. Finally, we arrive at the profound implications for information. Black holes, despite their destructive reputation, are also incredibly efficient at storing information. The entropy of a black hole, a measure of its disorder, is directly proportional to the area of its event horizon. This suggests that black holes might be the universe's ultimate information repositories. Some physicists even propose the holographic principle, suggesting that all the information about objects that fall into a black hole might be encoded on its two-dimensional surface, the event horizon, like a cosmic hard drive. For a civilization, this could open up incredible possibilities. Imagine a black hole-centric civilization attempting to tap into this information, perhaps using the black hole's own quantum properties, or even constructing vast quantum computers that leverage the extreme gravitational field to perform calculations beyond our wildest dreams. While the infamous information paradox still puzzles scientists, what truly happens to information that falls in? The theoretical implications are tantalizing. Perhaps the black hole isn't just a void, but a vast, silent library, holding the echoes of everything that has ever crossed its threshold. Communication, too, could take on new dimensions. While direct communication across extreme time dilation zones would be complex, the very fabric of spacetime near a black hole might allow for novel ways of encoding and transmitting data, perhaps even harnessing subtle quantum entanglement effects over vast distances, facilitated by exotic matter structures that manipulate local spacetime. Building around a black hole requires not just ingenuity, but a profound understanding and mastery of gravity itself. These megastructures wouldn't just orbit. They would be integrated with the spacetime around the black hole, perhaps using exotic matter to counteract tidal forces or stabilize orbits incredibly close to the event horizon. They would be worlds unlike any other, where the fabric of reality is not just a backdrop, but an active participant in their very existence, a canvas for the most audacious dreams. This truly is a frontier of cosmic engineering, where the wildest theories become the blueprints for tomorrow's cities. As we pull back from the event horizon of these magnificent imagined civilizations, let us ponder how these same principles of energy, time, and information might manifest in other incredible megastructures, perhaps not quite so close to the ultimate cosmic maw, but equally awe-inspiring in their scale and ambition. Join us next as we journey further into the realm of the truly colossal. And so, as we drift deeper into the cosmos, our minds alight with the possibilities, we come to a truly astonishing concept: the idea that a black hole, often seen as the ultimate cosmic destroyer, could in fact be the ultimate cosmic powerhouse. Imagine, if you will, a civilization not merely surviving near a black hole, but thriving, drawing its very lifeblood from its gravitational embrace. This is the heart of gravitational energy harvesting, a profound dance with space-time itself. At the core of this audacious idea lies a specific, almost magical region around a spinning black hole known as the ergosphere. Picture a vast, swirling whirlpool, but instead of water, it's space-time itself that's being dragged along. This phenomenon, called frame dragging, is a direct consequence of the black hole's immense rotation. As the black hole spins, it twists and pulls the very fabric of space and time around it, much like a giant's hand stirring a cosmic brew. The ergosphere is the outermost layer of this cosmic vortex, a region where space-time is moving so rapidly that it's impossible to stand still. You are compelled to rotate with the black hole, even if you try your utmost to resist. Now here's where it gets truly fascinating. Unlike the event horizon, that point of no return from which nothing, not even light, can escape, the ergosphere offers a peculiar kind of freedom. You can still escape from the ergosphere, given enough thrust. But within its bounds, a remarkable energy extraction mechanism, first proposed by the brilliant physicist Roger Penrose, becomes theoretically possible. This is the renowned Penrose process. Imagine a highly advanced civilization, perhaps one that has mastered matter and energy on a scale we can barely fathom. They might launch a specially designed probe or even a stream of carefully engineered particles towards a spinning black hole. This probe isn't meant to simply fall in. Instead, it's guided with exquisite precision into the ergosphere, that swirling, energetic realm. Once deep within this cosmic maelstrom, a critical maneuver takes place. The probe is designed to split into two pieces. One piece, let's call it the sacrifice particle, is directed to fall across the event horizon. But here's the trick. Because of the extreme conditions within the ergosphere, this sacrifice particle can actually carry negative energy relative to an observer far away. It's a concept that sounds counterintuitive, almost like stealing from empty space. But in the warped geometry of a black hole's ergosphere, it's a real, albeit strange, possibility. As this negative energy particle spirals into the black hole, it effectively reduces the black hole's rotational energy. It's as if the black hole, in consuming this particle, becomes slightly less energetic, spins ever so slightly slower. But what about the other piece? The energy particle, freed from its companion, now escapes the black hole's gravitational pull. And here's the marvel. Thanks to the energy it's siphoned from the black hole's rotation via its partner's sacrifice, this escaping particle now possesses more energy than the original probe had when it was first launched. It's like a cosmic slingshot, but one that leaves the slingshot slightly weaker each time, while the projectile flies away with an amplified burst of power. The black hole's rotational energy is literally being converted into usable kinetic or electromagnetic energy, harvested by these incredibly clever cosmic engineers. Think of it as a grand cosmic waltz, where the black hole is the dancer whose spin slowly diminishes with each step, and the civilization is the partner who elegantly extracts that rotational momentum, transforming it into light, heat, and power. This stolen spin, this harvested energy, is immense. A supermassive black hole spinning at nearly the speed of light holds an almost unfathomable reservoir of rotational energy, energy equivalent to billions upon billions of suns. Even a small fraction of this could power entire star systems for eons. Civilizations capable of such feats would truly be masters of their destiny. Imagine cities built not on planets but in vast orbital habitats, perhaps even colossal Dyson spheres or swarms of structures intricately woven around the ergosphere of a supermassive black hole. These black hole engines would provide an energy source so profound, so constant, that scarcity would become an alien concept. Their technology would allow them to build wonders beyond our wildest dreams, to terraform barren worlds, to explore the furthest reaches of their galaxy, and perhaps even to transcend their physical forms. The challenges of living so close to such a gravitational behemoth, the radiation, the tidal forces, would have been overcome by engineering marvels we can barely conceive, turning a cosmic threat into a cosmic gift. And of course, even this cosmic battery has its limits. As the black hole slowly spins down, it becomes less efficient at the Penrose process. Eventually, after eons of diligent harvesting, it would lose all its rotational energy, becoming a Kerr black hole, transforming into a Schwarzschild black hole, a non-spinning cosmic entity, still powerful, but no longer yielding its rotational secrets. But by then, such a civilization might have mastered other forms of energy extraction, or perhaps even found a way to recharge their black hole, though that is a story for another time. For now, let's simply marvel at the elegance of it all. The universe offering up its deepest secrets, allowing intelligent life to not just exist, but to flourish in the most extreme environments. The energy from a black hole's spin, a silent, swirling power, waiting to be claimed by those with the ingenuity and courage to reach out and touch the very fabric of space-time. And with such power at their fingertips, a civilization could indeed bend time itself to their will. But how would time actually shape these civilizations? Let us explore the profound impact of gravitational time dilation on societal structures. If taken to its most extreme and fascinating conclusions, imagine, if you will, not just people existing within the gentle flow of Earth-time, but entire societies that have learned to harness the very fabric of space-time itself. For this, we must turn our gaze to the cosmos's most enigmatic architects, black holes. These cosmic behemoths, born from the collapse of massive stars, warp space and time around them in extraordinary ways. It's here, in the gravitational embrace of a black hole, that the phenomenon we call gravitational time dilation becomes not just a scientific curiosity, but a foundational element of existence. Close to a black hole, where gravity is immense, time slows down significantly relative to observers far away. A subjective hour spent near the event horizon, that point of no return, could correspond to days, weeks, or even centuries passing in the distant, less gravitationally distorted universe. The gravitational pull is so profound that it literally stretches the very fabric of space-time, making clocks tick more slowly, atoms vibrate at a more languid pace, and life itself unfold at a stately, drawn-out rhythm. Consider, then, the audacious vision of civilizations built around these temporal titans. Picture vast, intricate habitats, not unlike orbital cities, but strategically positioned at varying distances from a black hole's singular heart. Imagine structures that gleam in the perpetual twilight, intricately designed to withstand unimaginable tidal forces, their inhabitants living within a carefully calibrated temporal gradient. Some settlements might orbit further out, experiencing time at a rate only slightly slower than what we know. Others, however, might venture daringly close, their existence a slow-motion ballet against the backdrop of a speeding universe, their very being a testament to humanity's yearning to master the fundamental forces of the cosmos. Wow. The energy advantages alone would be staggering. A black hole's accretion disk, the swirling vortex of superheated gas and dust spiraling inwards at incredible speeds, radiates immense amounts of energy, far outshining entire galaxies. This raw, untamed power, born from the friction and compression of matter falling into the abyss, could be harvested to fuel these cosmic metropolises for eons. It's a clean, virtually inexhaustible energy source, a cosmic furnace providing light and warmth where there would otherwise be only cold vacuum. But beyond mere energy, it's the manipulation of time itself that offers the most profound and transformative advantages. Imagine a specialized zone, a temporal sanctuary, meticulously engineered to hover just outside the event horizon. Within this sanctuary, scientists, artists, and philosophers could dedicate themselves to projects requiring immense subjective time. A grand unified theory, the unraveling of dark matter's secrets, the composition of an epic symphony that takes millennia to unfold in its subtle shifts and harmonies, all could be undertaken here. For the inhabitants, perhaps only a few subjective years or generations would pass, while outside, entire stars would be born and die, civilizations would rise and fall. Their intellectual pursuits would bloom and bear fruit over timescales incomprehensible to conventional societies, allowing for an accumulation of knowledge, wisdom, and creative output that would make them living libraries, veritable time capsules of thought and innovation. 1,000 Earth years could be but a leisurely subjective decade for them, allowing for a depth of contemplation and refinement we can only dream of. Conversely, distant outposts far from the black hole's gravitational grip could serve as rapid response units. If a critical decision needed to be made, or a sudden cosmic threat emerged, perhaps a rogue asteroid or a distant supernova's subtle, evolving energy signature, these fast-time inhabitants could observe the unfolding of events near the black hole in compressed subjective time. They could react with a swiftness that would appear instantaneous to those within the slower zones, acting as the nervous system's rapid reflexes while the inner core pondered. This creates a delicate, dynamic interplay, a societal rhythm dictated not by sunrises and sunsets, but by the differential ticking of cosmic clocks. Information itself would become a liquid, flowing through different temporal currents. Imagine sending a complex data set, perhaps an entire library of accumulated human knowledge or intricate simulations of potential futures, towards the black hole. As it approached the slow time zone, its rate of processing, if we imagine advanced AI systems residing there, would appear to accelerate from an external perspective. What would take millions of years for a conventional supercomputer could be crunched, analyzed, and synthesized into profound insights in mere subjective moments for a system strategically placed near the black hole. This makes black holes not just energy sources, but ultimate computational engines, processing the universe's most intricate problems in what feels like an instant to those within. They could become cosmic hard drives, where information ages gracefully, preserving itself for eons, or even time banks for priceless data, vital genetic codes of endangered species, intricate blueprints of lost technologies, to be retrieved millennia hence when conditions are ripe for their reintroduction into the universe. These temporal advantages would inevitably forge new societal structures, creating a hierarchy perhaps unlike any Earth has ever known. Those who dwell closest to the black hole, the chrononauts or temporal sages, might be revered as living oracles, their minds repositories of ages, of accumulated wisdom. Their very presence would radiate a gravitas born of eons, their gaze perhaps holding the weight of millennia of observation. Their pronouncements would carry immense weight, having been formulated and refined over subjective eons. They would be the deep thinkers, the long-term planners, the guardians of cosmic memory. Their understanding of cause and effect, honed over countless subjective centuries, would grant them an almost prescient insight into the unfolding of galactic history. Plun. The economy of such a civilization would undoubtedly be transformed. Time itself might become a precious commodity, a currency. Services could be priced not just in resources or labor, but in subjective temporal units. Want a complex philosophical treatise that takes centuries to write? That's a long time investment. Need a rapid-fire strategic analysis of a cosmic event? That's a fast-time sprint, commanding a premium. This would lead to novel forms of social stratification, where access to different temporal zones might define one's standing or one's role in the grand cosmic endeavor. The concept of saving time would take on a literal existential meaning, as individuals or groups might strategically slow down their own subjective experience to accomplish tasks or simply prolong their perceived existence. Communication across these vast temporal divides would be a formidable challenge, requiring sophisticated methods. Imagine messages sent on highly energetic beams of light, meticulously timed to arrive at a slower zone at a particular subjective moment. Or perhaps specialized temporal couriers, beings or drones engineered to withstand the extreme gravitational gradients, acting as living bridges between the different temporal currents, carrying information and even physical objects from one epoch to another. A single conversation could span millennia for an external observer, yet feel like a continuous, unbroken dialogue for the participants in their respective time frames, each waiting for their turn to speak across the chasm of eons. Cultural expressions would likewise evolve to reflect this temporal tapestry. Art might be created not to be appreciated in a single sitting, but to unfold over subjective centuries, its subtle layers revealing themselves to successive generations of a slow-time artist's descendants. Music could be composed with variations that evolve over eons, requiring an understanding of temporal scales far beyond our current grasp, perhaps even becoming sonic tapestries that slowly shift through galactic history. Architecture might be designed to undergo geological weathering as part of its aesthetic, its beauty revealing itself only after millennia of slow, deliberate change, each crack and erosion mark adding to its profound story. Literature would become sprawling sagas, conceived and refined over ages, each chapter a masterpiece unto itself, yet part of an even grander narrative. And the ultimate purpose of such a civilization would likely transcend mere survival. With the ability to manipulate time, they could embark on projects of truly cosmic scope. Perhaps they would dedicate themselves to the long-term preservation of the universe's biodiversity, safeguarding entire ecosystems in temporal havens until conditions are favorable for reintroduction across the cosmos. Or they might engage in grand-scale astrogation, slowly traversing galactic distances, their subjective journey a mere blink compared to the objective eons passing around them. Their goals would not be measured in years or decades, but in epochs, in the lifespan of stars and galaxies, engaging in cosmic diplomacy or even subtle, long-term galactic engineering. Yet, this utopian vision isn't without its shadows. The ultimate frontier of the black hole, the event horizon, remains an impassable barrier. Crossing it means an irreversible journey into the singularity, a one-way trip into the unknown. This creates a profound sense of existential dread and wonder, a constant reminder of the thin line between temporal mastery and ultimate oblivion. Furthermore, the psychological impact of living on vastly different timescales within the same society could be immense. How does one maintain empathy and connection with those whose subjective experience of life might be fundamentally different, where a childhood friend could age into a distant ancestor in what feels like a blink? The melancholic beauty of watching entire lineages rise and fall outside your subjective lifetime, or the silent gulf that could grow between a parent and child, would be immense challenges. The challenge lies in weaving these disparate temporal threads into a coherent, compassionate societal fabric. But for now, let us marvel at the sheer audacity of this idea. A civilization not just surviving, but thriving by embracing the deepest mysteries of time and gravity. A society where the whispers of a single generation can echo through what we would perceive as cosmic eons, where wisdom is literally accumulated over the lifespan of stars, and where the very rhythm of life is a symphony of varying tempos. As we drift deeper into the night, let us ponder the myriad ways that the universe, in its boundless ingenuity, might shape the very essence of existence, and how time, that most fundamental of dimensions, might be far more fluid and malleable than our daily lives suggest. What other cosmic secrets, what other dances of spacetime await our discovery, ready to reshape our understanding of what it means to be and to become? And so, as we drift deeper into the cosmic night, our thoughts turn from the swirling energy and the stretched whispers of time around a black hole to perhaps its most profound secret, its immense potential as the universe's ultimate vault of knowledge, a cosmic hard drive unlike any other. We speak now of the information advantages that such a gravitational behemoth might offer, advantages that could reshape our very understanding of memory, history, and the future of advanced civilizations. Imagine for a moment the sheer, unimaginable volume of information that a truly ancient and advanced civilization might accumulate. Not just the knowledge of their own world, their art, their sciences, their entire cultural heritage, but perhaps the observations of 1,000 star systems, the histories of countless species, the collected wisdom of an entire galactic arm. Where would you store such an ocean of data? Our earthly methods, with their delicate magnetic fields and fragile silicon chips, feel like fleeting scribbles on sand compared to the timescales and scales of the cosmos. We search for permanence, for an archive that can withstand the eons, a library that transcends the death of stars and the collision of galaxies. This is where the elegant framework of information theory softly steps into our cosmic story. At its heart, information theory, pioneered by the brilliant mind of Claude Shannon, gives us a way to quantify knowledge, to measure the reduction of uncertainty. Every choice between two possibilities, every yes or no, every on or off in a computer, represents a bit of information. It's the most fundamental unit of knowledge, like the smallest atom of meaning. And just as thermodynamic entropy measures the disorder in a physical system, information entropy measures the uncertainty inherent in a message. The more information we have, the less uncertainty there is. For a civilization, preserving information is like preserving order, holding back the tide of cosmic oblivion. For a long time, black holes presented a profound challenge to this idea. Early understanding suggested that anything falling into a black hole was utterly lost, crushed out of existence, its information gone forever. This no-hair theorem suggested black holes were featureless spheres defined only by their mass, charge, and spin, devoid of any unique hair of information. A cosmic incinerator, utterly destroying the precious bits that make up reality. This deeply troubled physicists because the laws of quantum mechanics suggest information should never truly be destroyed, only transformed. Then came the revolutionary insights of Jacob Bekenstein and Stephen Hawking, illuminating the black hole's event horizon as far more than just a point of no return. They revealed that black holes, contrary to earlier beliefs, possess entropy, a measure of their internal disorder, much like a gas of particles. And astonishingly, this entropy isn't proportional to the black hole's volume, but to the surface area of its event horizon. Think of it like this. If you have a box of gas, its entropy depends on how much gas is inside. But for a black hole, its disorder or information content depends on the size of its outer boundary, that shimmering veil where light can no longer escape. This was a radical departure, a profound whisper from the universe itself. This led to one of the most mind-bending concepts in modern physics, the holographic principle. Imagine a hologram, a flat, two-dimensional surface that contains all the information needed to reconstruct a full, three-dimensional image. The holographic principle suggests that the entire three-dimensional reality of our universe might, in some profound way, be encoded on a distant, two-dimensional surface, a cosmic horizon far, far away. In the context of black holes, it means that all the information about everything that has ever fallen into a black hole isn't lost within its impenetrable depths, but is instead somehow painted or projected onto the two-dimensional surface of its event horizon. The event horizon becomes an ethereal canvas, a cosmic blackboard upon which the history of all that crosses it is recorded. And what a canvas it is. The amount of information that can be encoded on this surface is truly staggering. Physicists have calculated the maximum information density possible in any region of space, a limit known as the Bekenstein bound. Black holes achieve this theoretical maximum. The smallest possible unit of area in the universe, defined by the Planck length, is incredibly tiny, far smaller than an atom, far smaller than even a proton. Imagine dividing the event horizon of a black hole into these fundamental pixels of space. Each of these Planck areas, it is theorized, can hold approximately 1 bit of information. Just 1 bit, yes, but when you consider the sheer immense surface area of even a stellar mass black hole, the numbers become truly astronomical. Consider a black hole just a few times the mass of our Sun. Its event horizon, though seemingly empty space, would be composed of an almost incomprehensible number of these Planck-sized pixels. The information it could theoretically store would far exceed all the data ever generated by humanity. Every book, every song, every film, every internet page, every thought recorded, multiplied by factors that dwarf our current understanding of scale. It's like trying to compare a grain of sand to all the beaches on Earth. A supermassive black hole residing at the heart of a galaxy could potentially act as an archive of truly galactic proportions, holding the histories of entire clusters of stars. The advantages of such cosmic data storage are compelling. Firstly, the sheer density is unparalleled. No conventional storage medium could ever come close to encoding so much information into such a compact space. Secondly, and perhaps even more critically for civilizations thinking on cosmic timescales, is the longevity and stability of black holes. While black holes do slowly evaporate over incomprehensibly vast periods of time through a process known as Hawking radiation, for stellar mass black holes, this process takes far, far longer than the current age of the universe. We're talking about time scales of billions of billions of billions of years. This makes them ideal for truly eternal archives, repositories of knowledge meant to survive the death of stars and the slow heat death of the universe itself. For a civilization built around a black hole, this isn't just a theoretical curiosity. It could be the foundation of their very existence, their entire collective consciousness, their cultural heritage, their scientific discoveries, perhaps even the blueprints for new realities or the genetic codes of long-extinct species could be encoded and preserved on the event horizon. It transforms the black hole from a cosmic devourer into the ultimate librarian, a silent, ancient keeper of secrets. Imagine navigating the universe with such an ultimate backup system, where all knowledge is secure, not in fragile boxes, but in the very fabric of space-time whispered across the event horizon. Such a civilization wouldn't just be mining energy or manipulating time, they would be accessing and curating the most profound data store the cosmos has to offer. And as we gently consider these possibilities, we might wonder, if black holes are such perfect libraries, how would one read their endless volumes? How would these advanced civilizations access and interact with the information so deeply woven into the tapestry of space-time? That, perhaps, is a secret for another time, another cosmic whisper as we journey deeper into the night. And so, as we drift deeper into the cosmic night, let us reconsider these silent giants, the black holes. For all their reputation as ultimate cosmic vacuum cleaners, swallowing light and information without a trace, the universe often holds secrets even more profound than its obvious power. Imagine, if you will, a deep, resonant hum, a whisper echoing from what we once believed was an absolute void. This, my dear listeners, is the subtle yet utterly transformative sound of Hawking radiation, a symphony of quantum mechanics playing out on the very edge of oblivion. Stephen Hawking, a brilliant mind who understood the universe in ways few others ever have, painted a picture that forever changed our understanding of black holes. He suggested that these cosmic behemoths aren't truly black in the absolute sense. Instead, they glow faintly, a ghostly luminescence born from the very fabric of space-time itself. It's a dance of quantum particles, an intricate ballet that takes place right at the event horizon, that point of no return, the threshold beyond which nothing, not even light, can escape. Think of the vacuum of space, not as an empty void, but as a restless sea of potential energy, constantly churning with fleeting activity. Here, ephemeral pairs of particles and their antimatter twins are spontaneously created and annihilated in an instant. A cosmic borrowing and repaying of energy that happens everywhere, all the time. But at the event horizon of a black hole, this delicate balance can be catastrophically disrupted. Imagine one particle of such a pair being born just inside the event horizon, inexorably pulled into the black hole's embrace, while its twin, by pure chance, emerges just outside, free to escape into the wider universe. It's like a cosmic door opening and closing, but with an imbalance. When this happens, the particle that escapes carries away positive energy, while its unfortunate sibling that falls in is often associated with carrying negative energy relative to the distant observer. This isn't truly negative energy in the sense we might imagine, but rather a mechanism by which the black hole itself pays for the escaped particle's energy, effectively losing a tiny fraction of its own mass. Over vast stretches of cosmic time, this continuous emission of particles, this Hawking radiation, causes the black hole to slowly, imperceptibly shrink, ultimately leading to its complete evaporation. It's a profound thought. Even the most insatiable monsters of the cosmos eventually fade away, their existence whispering into oblivion. For a black hole the size of our sun, this radiation is incredibly faint, colder than the deepest vacuum of space. The energy emitted is so minuscule, so spread out, that it would be utterly impossible to harness for any practical purpose with current technology. It's a distant, academic glow, like a single firefly in the heart of a galaxy. Yet this is where the extraordinary concept of quantum engineering entwines with the potential of Hawking radiation utilization for advanced civilizations. What if the black hole wasn't a monstrous sun-sized entity, but something far, far smaller? Imagine not a stellar mass black hole, but a micro black hole. These are not natural phenomena we observe readily, though some theories suggest they might have formed in the chaotic crucible of the Big Bang itself. Tiny, ancient relics we call primordial black holes, or perhaps a civilization advanced enough could create them. And here's the crucial twist. The smaller the black hole, the more intensely it radiates and the hotter it becomes. A black hole with the mass of a large asteroid, for example, would radiate with the power of a mighty star, searing hot and furiously energetic. A black hole the size of a mountain, even more so. It's an inverse relationship. Smaller mass means greater curvature at the horizon, leading to more potent quantum effects. Now, envision a civilization that has mastered not just astrophysics, but also quantum engineering, the precise manipulation of matter and energy at the most fundamental subatomic levels. Such a civilization wouldn't just observe a micro black hole, they would engineer around it, turning a theoretical curiosity into a fundamental pillar of their existence. Picture vast, intricate structures woven around a precisely contained micro black hole, perhaps just meters or even centimeters across, humming with controlled power. This wouldn't be a random, chaotic emission, but a carefully managed outflow of pure energy. Plan. Quantum engineering would allow them to design quantum collectors, perhaps using supercooled quantum materials, to efficiently capture every photon, every stray particle of Hawking radiation. They might even devise quantum gates and resonators that could amplify or direct specific frequencies of this radiation, tuning the black hole's output like a celestial radio. Imagine a miniature sun, stable and incredibly potent, radiating pure, clean energy for millennia, powered by the slow, stately evaporation of a meticulously engineered quantum object. These civilizations wouldn't just be living near black holes, they would be living off them, drawing sustenance directly from the quantum fabric of space-time. But energy is only one facet. Black holes, and by extension their Hawking radiation, also touch upon the profound mysteries of information. The famous information paradox asks whether information that falls into a black hole is truly lost forever, or if it is somehow encoded, perhaps scrambled, within the Hawking radiation. For a civilization capable of quantum engineering, this isn't just a philosophical question. It's a potential frontier of knowledge and communication. Could they build quantum siphons, designed to analyze the delicate quantum correlations within the emitted particles, seeking to decode the echoes of matter and energy that once crossed the event horizon? Imagine a library of lost cosmic histories, not perfectly retrievable perhaps, but offering tantalizing glimpses into what the black hole has consumed over eons. Or, even more mind-boggling, could they use the extreme quantum environment near the event horizon itself as a platform for unparalleled quantum computing? A place where information could be stored with unimaginable density and processed with speeds limited only by the curvature of space-time itself, leveraging quantum entanglement and superposition on a scale we can barely comprehend. The black hole becomes not just a power source, but a living, breathing quantum brain, its subtle emissions carrying the weight of cosmic secrets. Such civilizations, weaving their existence around these engineered quantum marvels, would represent the pinnacle of scientific achievement. They would be masters of not just the macroscopic universe, but the microscopic quantum realm as well, bending its fundamental laws to their will. They would have truly tamed the wild energy of creation and annihilation, turning a theoretical curiosity into the engine of their entire civilization, building their future on the subtle whispers of evaporating space-time. And as we consider the vast implications of harnessing such fundamental forces, we begin to wonder about the next great frontier, how these civilizations might not just utilize, but also manipulate the very fabric of time itself, another profound advantage offered by the gravitational tapestry woven by black holes. But that, my friends, is a tale for another gentle moment, as the stars continue their silent journey across the cosmic canvas. Civilizations built around black holes are not merely a fanciful dream, but a profound contemplation of how life might thrive and evolve in the most extreme, yet paradoxically most advantageous corners of our cosmos. Imagine, if you will, not just orbiting a star, but orbiting a black hole, a titanic wellspring of gravitational power, a silent cosmic anchor in the fabric of space-time. Here, the very rules of existence, as we commonly perceive them, are bent and rewoven, offering unparalleled opportunities for those wise enough and advanced enough to harness them. At the heart of such a civilization's prosperity lies an almost inexhaustible energy source. Consider the accretion disk of a supermassive black hole, a swirling maelstrom of gas, dust, and plasma spiraling inward at incredible speeds. As this matter approaches the event horizon, it accelerates, compresses, and heats to unimaginable temperatures, radiating a torrent of X-rays and gamma rays into the surrounding space. This isn't just a powerful light show, it's a colossal cosmic power plant, a gravitational waterfall of energy that far outshines any star. A civilization could, theoretically, construct immense energy collectors, vast solar sails, designed not for starlight, but for the blinding brilliance of this accretion disk, converting its raw power into usable forms for their cities, their travel, their very lives. We call this the most efficient engine in the universe, turning matter into energy with an efficacy that dwarfs nuclear fusion. Beyond merely collecting this radiated energy, there are more intricate ways to draw power. The Penrose process, for example, hypothesizes extracting rotational energy directly from a spinning black hole. Imagine deploying colossal, specially designed structures or energy anchors into the ergosphere, the region just outside the event horizon where space-time itself is dragged along by the black hole's rotation. By carefully ejecting particles that then fall into the black hole and recovering the remaining fragments, a civilization could theoretically spin down the black hole, siphoning off its rotational energy like tapping into a cosmic turbine. It's a dance with gravity itself, a precise ballet where the energy of space-time becomes a vital resource. But the advantages extend far beyond energy. Time, that most elusive of dimensions, also becomes a malleable tool in the vicinity of a black hole. Gravitational time dilation, a cornerstone of Einstein's theory of general relativity, dictates that time passes more slowly in stronger gravitational fields. For inhabitants far from the black hole, their clocks would tick normally. But for those stationed closer to the event horizon, perhaps on an orbital habitat skimming the innermost stable orbit, time would crawl. Days for them might be years for their counterparts further out. This isn't just an interesting phenomenon, it's a strategic advantage. Imagine scientists working on incredibly complex calculations, or engineers designing monumental structures where every moment stretched into an eternity. Projects that would take millennia in normal space could be completed in mere decades from their perspective. Data archives could be built to last for cosmic ages, preserving knowledge against the relentless erosion of entropy, their precious information experiencing time at a glacial pace. It's like having a cosmic slow-motion chamber, a temporal incubator for profound thought and vast undertakings. And what of information itself? The black hole information paradox remains one of the universe's great enigmas, pondering whether information truly vanishes behind the event horizon. Yet, even without fully resolving that, The vicinity of a black hole presents fascinating opportunities. The extreme gravitational gradients and quantum effects near the horizon might, in ways we can only theorize, offer unique methods for information encoding, storage, or even transmission. Perhaps through entangled particles manipulated across vast distances, with one half of the pair anchored near the black hole, experiencing time dilation, while the other is used for communication. Such advanced techniques might allow for signals that are not just encrypted, but intrinsically woven into the fabric of space-time itself, secure against any conventional interception. With such mastery over fundamental forces, these civilizations would inevitably turn their gaze toward space-time manipulation for defense and resource access. Imagine a civilization not just living within warped space-time, but actively sculpting it. For defense, this could mean creating localized gravitational fields, dynamic space-time shields that could deflect incoming threats, asteroids, hostile projectiles, even fleets. Instead of physical barriers, they might generate ephemeral gravity walls that bend light and matter, causing an adversary's weapons to miss their target or even be flung away into harmless trajectories. Or perhaps more subtly, they could create regions of intense time dilation around strategic assets, effectively freezing threats in their tracks from the perspective of their own rapid-thinking defenders. For resource access, the possibilities deepen into the truly exotic. Beyond merely mining the energy of an accretion disk, these civilizations might have learned to harvest space-time itself. Theoretical physics suggests that creating stable wormholes, shortcuts through space-time, would require immense amounts of exotic matter, material with negative energy density. If such matter exists and can be manufactured or manipulated, then a civilization could, in principle, create and stabilize wormholes, not just for instantaneous travel across vast cosmic distances, but perhaps as conduits for rare elements from distant stars, or even as carefully managed taps into regions of space-time rich in other, as yet unknown, resources. They might even learn to extract subtle ripples from the cosmic gravitational background, not as a power source, but as a form of quantum information or a medium for truly universal communication, stretching across the entirety of the universe as easily as a conversation across a room. Such a civilization would not merely be an advanced species. It would be an architect of its own cosmic reality, a weaver of the fabric of space-time itself. They would demonstrate not just mastery of technology, but a profound understanding and control over the very fundamental laws of physics. They would be the ultimate pioneers, not just exploring the universe, but actively shaping it to their will, demonstrating a symbiotic relationship with a cosmic force that we, from our humble perspective, can only observe in awe. Their homes, their industries, their very existence would be a testament to what is possible when intelligence meets the raw, untamed power of the cosmos. And as we consider these profound possibilities, our minds open to the sheer ingenuity and adaptive capacity life might possess, prompting us to wonder what other secrets the universe holds, what other grand designs are etched into the space-time around us, waiting to be discovered or perhaps brought into being. Imagine, if you will, intelligences whose very concept of self, of time, and of the universe itself is forged in the most extreme crucible the cosmos can offer, the event horizon of a black hole. These are not just exotic life forms, they are living philosophies, sentient expressions of the universe's most profound gravitational mysteries. Their existence challenges our deepest assumptions about reality, consciousness, and the passage of time. For us, time flows like a relentless river, an unstoppable current carrying us from past to future at a uniform pace. But for these horizon-dwelling intelligences, time is a different creature altogether, a vast, sluggish ocean where every moment stretches into an eternity. This phenomenon, known as gravitational time dilation, is a cornerstone of Einstein's theory of general relativity. Near the immense gravitational pull of a black hole, clocks run profoundly slower for an observer closer to the mass compared to one far away. For beings dwelling right at the precipice, a single tick of their internal clock, a single beat of their communal heart, might correspond to eons for the rest of the universe. What does this do to their psychology? Consider their memory. For us, memories fade. Events recede into a blurred past. But for them, perhaps every memory is crystal clear, accessible with the vividness of the immediate present, because subjectively, less time has passed for them since the event occurred. A decision made millennia ago by our standards might feel as fresh as if it were made yesterday in their own experience. This could lead to an unparalleled depth of wisdom, where history is not a collection of faded stories, but a living, breathing tapestry of experience that continually informs their present. Conversely, the concept of future planning would be utterly transformed. What does it mean to plan for an event that, from their perspective, might occur in their tomorrow, but from an external observer's view, lies countless cosmic epochs away? Their societal evolution might appear glacially slow to an outside eye, yet for them it could feel perfectly paced, unfolding with a majestic, unhurried grace that allows for absolute perfection in their advancements. 1. Their very perception of the external universe would be wonderfully distorted. From their unique vantage point, the distant cosmos would appear sped up, a frenetic dance of galaxies rushing through their evolutionary cycles in what would be, for the horizon dwellers, mere instants. They might witness the birth and death of stars, the formation of galactic superclusters, and even the eventual heat death of the universe itself, all compressed into an unbelievably short, luminous spectacle. Imagine the existential awe, the profound sense of being witnesses to the entire cosmic drama, watching the universe play out its grand finale, while they themselves remain suspended in a timeless present. This isn't just observation. It's an intimate, accelerated communion with the very fabric of cosmic history. Their philosophy might revolve around this unique cosmic insight, making them ultimate chroniclers of reality, their very consciousness, a living library of universal evolution. Their physicality, too, would be exquisitely adapted to these extreme conditions. The tidal forces near a black hole are immense, capable of stretching an unadapted object into a long, thin strand, a process evocatively named spaghettification. Therefore, these intelligences could not be corporeal in our sense. Perhaps they are intricate patterns of energy, stable quantum fluctuations, or even vast, distributed networks of information existing as resonant frequencies, within the warped space-time itself. Their bodies might be composed of light or fields or something entirely beyond our current comprehension, capable of withstanding the crushing gradients of gravity. Their sensory organs, if they possess them, would perceive space-time directly, feeling its curvature, tasting its flow, hearing the silent symphony of its warp and weave. Their very senses would be extensions of general relativity. The event horizon itself, that shimmering silent frontier, would be more than just a physical barrier. It would be their ultimate horizon, the edge of their known world in a profound existential sense. It represents the absolute boundary of cause and effect, a point of no return from which nothing, not even light, can escape. For these beings, living eternally on its brink, the event horizon could be a source of endless fascination, a profound mystery, or even a sacred boundary. What does it mean to reside at the edge of the ultimate unknown, knowing that just a hair's breadth beyond lies a singularity from which no information can return, a realm where even space-time ceases to exist in a conventional sense? It might instill in them a unique blend of reverence and daring, an understanding of limits that shapes every aspect of their thought. And then there is the whisper from beyond the veil, Hawking radiation. The theoretical emission of particles from black holes, a slow, gentle outpouring that suggests black holes are not entirely black, not entirely isolated. This radiation, while incredibly faint for astrophysical black holes, carries with it a faint echo of the black hole's contents, and slowly, inexorably, causes it to evaporate over vast timescales. For these intelligences, this whisper might be their ultimate source of information, a cosmic radio signal from the heart of cosmic entropy. They might dedicate their existence to deciphering these incredibly subtle signals, to understanding the quantum information encoded within them. The famous wacky information paradox, the question of whether information is truly lost when it falls into a black hole, would be their most pressing philosophical puzzle, their grandest scientific quest. Their purpose might be to act as cosmic librarians, attempting to read the outgoing Hawking radiation, to reconstruct the universe's lost libraries, to solve the paradox not just theoretically, but through their very lived experience near the source of the mystery. Their lives, so impossibly alien, remind us that the universe holds infinite variations of consciousness, each shaped by its unique cosmic environment. The philosophy of a horizon dweller would be one of profound patience, of an unparalleled perspective on cosmic time, and of an intimate, terrifying, and awe-inspiring relationship with the fundamental forces of gravity and quantum mechanics. They are the universe's ultimate stoics, living on the grandest stage of cosmic drama, witnessing the unfolding of reality at its most extreme. Yet such philosophical depths pale before a grander question: how do these civilizations actually expand across the cosmos? And so, as the cosmic night deepens, we find ourselves contemplating the profound influence of black holes on civilizations bold enough to make them their home. Imagine, if you will, a future where entire societies don't merely observe these gravitational giants from afar, but choose to build their very homes around them. Societies forged in the crucible of extreme physics. These civilizations would expand across the cosmos, not by seeking new planets, but by seeking new black holes. Picture a civilization that has mastered the art of living on the edge of forever. Their primary power source isn't a fleeting star burning through its precious fuel in a few billion years, but an accretion disk, a swirling vortex of superheated gas and dust spiraling into a supermassive black hole. This disk, often hotter and brighter than a million suns, is a perpetual furnace, a cosmic river of energy. Specialized habitats, perhaps intricate Dyson spheres or vast orbital cities, would be constructed with breathtaking precision, designed to safely harness this boundless outpouring. Imagine colossal energy collectors, humming softly as they draw power from the disk's blinding light. Its intense magnetic fields, or even the sheer kinetic energy of its flow. This isn't just power, it's sustained power, virtually limitless for timescales that dwarf the lifespan of any star. It's an energy source that promises an almost eternal dawn for those who can tame its wild heart, granting them the means to fuel grand projects, to power vast computational arrays, and to sustain populations on scales we can barely conceive. The whisper of energy, drawn from the deepest gravitational well, would be the very pulse of their society, a constant, gentle thrum against the backdrop of the quiet void. But the allure of black holes extends far beyond mere energy. Perhaps the most profound advantage they offer is a dance with time itself. Near the immense gravity of a black hole, the very fabric of space-time warps and stretches. This phenomenon, known as gravitational time dilation, means that clocks tick slower for those closer to the black hole's event horizon compared to observers far away in less warped regions of space. For a civilization established in such an environment, time becomes a malleable resource, a precious commodity. Imagine orbiting habitats, meticulously positioned, where a single day for their inhabitants might correspond to weeks, months, or even years for those traveling interstellar distances. This offers an unparalleled gift: time to think, to plan, to innovate, to mature. Projects that would span generations in normal space could be completed within a single lifespan. Entire libraries of knowledge could be compiled and absorbed. It allows for a profound patience, a deep, unhurried wisdom to permeate their culture. For a historian living near a black hole, cosmic events unfold with stately grace, offering a unique slow-motion perspective on the universe's grand narrative. For a scientist, experiments could run for millennia, yielding insights unimaginable to those bound by the swift passage of time elsewhere. Time becomes a strategic asset, a deep well from which to draw, giving these civilizations an evolutionary edge, a profound ability to perceive and interact with reality on a different scale, as if observing the universe through a slow, deliberate gaze. And then there's the information advantage. Black holes, as the deepest gravitational wells in the galaxy, naturally become cosmic focal points. They act as gravitational anchors, steadying points in the swirling chaos of interstellar space. For advanced civilizations, these locations could become natural hubs for information gathering and processing. Imagine vast networks of sensors, painstakingly deployed throughout the black hole's sphere of influence, absorbing every stray neutrino, every gravitational wave ripple, every faint whisper of electromagnetic radiation from across the galaxy. The stable environment, the abundance of energy, and the temporal dilation could allow for the construction of super-advanced quantum computing arrays operating for eons, meticulously sifting through galactic data, uncovering patterns and connections invisible to less patient observers. These black hole civilizations could become the ultimate data architects, the librarians of the cosmos. Their immense computational power and extended timescales allowing them to build unparalleled models of the universe, predict cosmic events, and even perhaps decipher the deepest mysteries of physics. They could be the galactic internet's core routers, the central processing units of a vast interstellar network, their sheer gravitational pull attracting and centralizing information flow. Consider what such an existence implies for sharp interstellar expansion and network formation. A civilization that thrives around a black hole isn't just seeking new planets. They are seeking new black holes. Each black hole becomes a coveted node, a strategic jewel in a growing galactic web. The expansion isn't merely about spreading life, but about extending the network of these advanced societies, linking them together. Travel between these black hole outposts would be a meticulous, multi-generational endeavor, perhaps involving sleeper ships or advanced propulsion systems, with each journey ending at another gravitational lighthouse, another wellspring of energy, time, and information. These journeys might be planned over eons, their execution a testament to the patient foresight born of time dilation. As these black hole civilizations expand, they wouldn't just build isolated strongholds, they would weave an intricate all-black hole network. Imagine supermassive black holes at galactic centers serving as the ultimate hubs, interconnected by highways of lesser stellar mass black holes, each with its own orbiting civilization. This network wouldn't necessarily rely on exotic wormholes, but on the sheer strategic value of each black hole as a stable, energy-rich, time-dilated anchor in the vastness. Information, commodities, and perhaps even consciousness could flow through this cosmic tapestry, each node a library, a power station, a time sanctuary. This galactic infrastructure would be the ultimate expression of their mastery over extreme physics, a testament to their longevity and their unique perspective on the universe. Such a network would grant these civilizations a profound resilience, a collective intelligence that spans the entire galaxy. They would be the quiet, steady observers, the long-term planners, the guardians of cosmic memory. Their very existence would be a demonstration of life's incredible adaptability, its capacity to not just survive, but to flourish in the most extreme yet most advantageous corners of the cosmos. As we drift further into this imagined future, we begin to see a universe not just dotted with stars, but threaded with these powerful, enduring black hole havens, each a silent monument to what truly advanced civilizations might achieve. And as we consider these grand galactic networks woven from the fabric of space-time itself, we arrive at the ultimate question: what becomes of such civilizations when they have conquered energy, time, and information itself? Picture, if you will, the ultimate frontier they might reach, a place where the very fabric of existence is stretched and warped to its absolute limit, and civilizations have transcended the conventional understanding of what life can be. Here, not on a planet orbiting a gentle star, but in the profound silence and immense gravity of a black hole, perhaps one of the universe's most enigmatic creations, advanced societies might find their sanctuary, their power, and their path to cosmic transcendence. Imagine these architects of the void, not fearing the cosmic devourer, but embracing it, building vast megastructures that dance on the precipice of oblivion. The first, and perhaps most compelling advantage these societies would harness, is the sheer, boundless energy that a black hole provides. A stellar mass black hole, born from the collapse of a giant star, is not just a void. It is a dynamic, pulsating heart of gravitational power. As matter, dust, gas, even unfortunate stars spirals inward towards the event horizon, it forms a brilliant, fiery accretion disk. This is not just any disk. It is a cosmic furnace where friction and immense gravitational forces heat the infalling material to millions of degrees, causing it to glow with blinding intensity, emitting torrents of X-rays and gamma rays. For a black hole civilization, this accretion disk would be their primary sun, their endless power plant, far surpassing the energy output of any main sequence star. They would engineer vast harvesting mechanisms, perhaps colossal Dyson spheres or swarms of collectors, to capture this titanic outpouring of radiation, converting it into usable energy to power their entire civilization, their vast computational networks, and their ambitious projects that span cosmic eons. And for those truly advanced, there's another, more sophisticated energy source, the Penrose process. For a spinning black hole, known as a Kerr black hole, space-time itself is dragged around its rotation, creating a region called the ergosphere. Within this ergosphere, even light cannot remain stationary relative to a distant observer. The Penrose process theorizes that objects could enter this region, split into two parts, and have one part fall into the black hole while the other escapes, carrying away more energy than it initially possessed. It's like siphoning off the very spin of the black hole, a gravitational theft on a cosmic scale, extracting rotational energy from the black hole itself. Imagine harnessing this spin, gently decelerating the black hole over quadrillions of years to power an existence beyond our comprehension. And in the unimaginably distant future, when all other energy sources have dimmed, there's the theoretical whisper of Hawking radiation. While negligible for stellar mass black holes in our current epoch, causing them to evaporate over timescales far longer than the current age of the universe, it offers a glimpse into an ultimate, albeit tiny, energy source that ensures a black hole is not truly black, but slowly, imperceptibly radiates away its mass. Beyond raw power, black hole civilizations would experience an extraordinary manipulation of time. This is due to the phenomenon of gravitational time dilation. Near a black hole, the fabric of space-time itself is so dramatically warped that time, for those living in its immediate vicinity, would flow at a different, slower pace compared to observers far away in the flatter reaches of the universe. For those on a planet orbiting a distant star, eons might pass. Stars might be born and die. But for the inhabitants nestled close to the black hole's event horizon, only a fraction of that subjective time would have elapsed. Imagine the profound implications. Scientific research projects that would take millennia in normal time could be completed in mere centuries from the perspective of the black hole dwellers. Vast, complex computations charting the course of cosmic evolution or solving the deepest mysteries of physics could be undertaken with impatience born of temporal abundance. They would become masters of their own subjective timeline, able to accelerate their internal processes relative to the external universe, a temporal haven where contemplation and long-term planning reach unprecedented scales. They could effectively wait out cosmic catastrophes, experiencing the universe's eons as brief seasons, emerging into a future vastly changed, but having experienced it in a comparatively short, subjective span. And then there are the immense information advantages. The black hole itself, in a way, becomes a cosmic fortress, a shield against the violent whims of the universe. Protected within its deep gravitational well, these civilizations would be largely impervious to supernovae, gamma-ray bursts, and other energetic phenomena that scour the intergalactic medium. Their very existence is cloaked by the black hole's immense gravity, making them an ultimate cosmic sanctuary. Moreover, the profound density and stability of the black hole environment could offer unparalleled opportunities for information storage and processing. Imagine libraries of data, encoded in structures that leverage the very curvature of space-time, or computers that can perform calculations over subjective eons while the rest of the universe rushes past. The information paradox, though a theoretical puzzle, hints at the profound way black holes interact with information, suggesting they might be ultimate repositories, albeit in ways we don't yet fully grasp. For a civilization, the ability to collect, process, and safeguard vast amounts of knowledge over cosmic timescales, protected from external threats and gifted with temporal flexibility, would represent an evolutionary leap of staggering proportions. These black hole societies aren't just surviving, they are transcending the conventional limitations of stellar civilizations. They are riding the deepest currents of space-time, enduring far beyond the lifespan of ordinary stars, perhaps even beyond the collapse of entire galaxies. They are charting a course toward an ultimate cosmic destiny, equipped with advantages that defy our current understanding of what life and civilization can achieve. Their existence would be a testament to ingenuity, adaptation, and an unyielding will to navigate the universe's most extreme conditions, witnessing the final acts of the cosmic drama unfold from their unique, time-dilated vantage point. And as we consider the ultimate fate of such profound societies, we might wonder how they would approach the very fabric of their being and what secrets of information they might unlock in their endless temporal havens. And so, as the velvet curtain of night gently descends around us, let us softly reflect on the extraordinary journey we've taken together. We've peered not with the harsh glare of a telescope, but with the quiet contemplation of a dream into a realm where civilizations whisper into existence, not just near, but around the most profound mysteries of the universe, black holes. Picture once more, if you will, the gentle hum of a world powered by an almost unimaginable generosity. No frantic searching for resources, no desperate struggle against the encroaching dark. Instead, imagine a civilization cradled in a perpetual embrace of energy, drawn not from finite reserves, but from the very dance of space-time around a cosmic heart. This wasn't a fierce, roaring power, but a deep, resonant calm, a steady, unending warmth that nurtured every endeavor. The sheer abundance, the quiet promise of boundless sustenance, would allow for an existence unburdened by scarcity, fostering an era of creativity and peace we can scarcely fathom. Every thought, every invention, every artistic expression powered by the cosmic ballet, resonating with the silent grandeur of the universe itself. It's a vision of energy, not as a commodity, but as a harmonious, ever-present gift, allowing minds to soar unfettered by mundane concerns. Then, let your thoughts drift to the notion of time, stretched and folded around these celestial behemoths. Remember how, for these patient beings, moments unfurled like the slow, deliberate opening of a rare bloom. Days might feel like our years, and centuries like our fleeting seasons. This wasn't a rushing river of existence, but a deep, still lake, reflecting the stars in its profound depths. What wisdom could be gathered in such an expanse of time? What insights could blossom when thought is unhurried, when reflection is not a luxury, but a way of being? Imagine the deep, abiding patience, the careful consideration, the rich tapestries of knowledge woven over eons. Lifetimes extended beyond our wildest imaginings, not in a feverish chase for more, but in a tranquil, profound immersion in the very fabric of existence. Every whisper of history, every quiet innovation, every unfolding philosophical truth granted the spaciousness to truly mature, to be understood in its fullest, most serene context. And finally, consider the quiet majesty of information, conserved and perhaps even accessed within these cosmic guardians. Picture the black hole not just as a devourer, but as an ultimate silent archive, a place where the universe's most profound secrets might be held in a state of ultimate stability. For these civilizations, information wasn't a fragile whisper on a transient medium, but perhaps a fundamental aspect of their very environment, etched into the cosmos itself. Imagine the quiet reverence with which knowledge would be approached, understanding not as something to be frantically acquired, but as a deep, abiding connection to the universe's ultimate truths, the answers to cosmic riddles, the echoes of forgotten eras, the very blueprints of reality, held in a profound, unchanging stillness. It would foster a deep understanding, a quiet contemplation of the interconnectedness of all things, where the boundaries of self and cosmos gently blur. So, we've walked through realms of endless energy, stretched out time, and conserved information, painting a gentle portrait of civilizations deeply attuned to the universe's most wondrous and mysterious phenomena. They are not conquerors of the black hole, but harmonious partners, living in quiet awe and profound symbiosis. Their existence is a testament to what might be possible when the very laws of physics are embraced, not fought against, leading to a kind of cosmic serenity. Now, as the day's last light truly fades, and your own journey into slumber begins, carry these gentle images with you. Let the thought of boundless energy warm your sleep. Let the vastness of time bring peace to your mind, and let the quiet whisper of cosmic knowledge reassure your dreams. There's no rush, no urgency, just the soft, steady rhythm of the universe embracing you. Close your eyes now, dear one. The stars are watching over you, and the mysteries of the cosmos are waiting to unfold in your own peaceful dreams. The journey continues quietly, wonderfully, in the gentle depths of your own imagination. Good night, sleep soundly, and may your dreams be as vast and as tranquil as the universe itself.